Hey guys, it's time for another Pierson Workholding Q&A. In this week's episode, we're talking machining in general. Questions for this episode. How do you manage tool life? How do you reduce setup time? And how do you guys as a company reduce crashes? Great questions. Let's jump right in. So number one, how do you manage tool life? So if you look behind us, we primarily have Haas mills and Doosan lathes. Now, the Haas mills, they have a built-in thing of tool life management where it will alarm out or warn you or something after you've used the tool 50, 100, 2,000 times, whatever the number may be. We haven't really found that to be very helpful because how do you know how long an end mill is gonna last? How do you know how much life you can get out of a drill? Unless you already know that number. Historically, we don't really keep a lot of records on how long a drill actually lasts. I mean, we have some drills that are going on 10 years because we only cut aluminum and they're almost as sharp as day one. But we've found this little thing that is kind of buried, or at least I don't hear a lot about. So if you go into the Haas control, hit current commands, go up to the top, go to ATM, that's Advanced Tool Management. And right there, there's a section where you can set the maximum spindle load. So for example, when we run an end mill and we just run our program, the first time we go through it, we'll set the maximum as maybe like 50% and see if it gets all the way through the cut. If it doesn't, we kind of bump that number up. The point is to find the maximum tool load at the beginning of your production run with a nice sharp tool. So say that we run that tool one, maybe it's like a 1/2 inch rougher, and it maxes out at 85%. We will set the maximum allowable load to 95%. As that tool dulls and it creeps up, because it's a higher spindle load if the tool is dull, and it hits that 95%, it'll stop, it'll alarm out. Say you misload a part, and like if you're using a vise and it shifted off to one side, it goes to round a corner where there's excessive amounts of material, it'll jump way up in the spindle load and alarm out. That has saved us lots of times over the years. It also doesn't rely on a number of uses. It relies on an actual number that you can see right away, which is spindle load. So that's how we manage tool life. Next question, how do you reduce setup time? For us, we do two things. We standardize all our tools. So behind me, there's two machines that are dedicated exclusively to two separate product lines. And in that, for example, our VF4SS has a 30+1 tool capacity. All 30 tools are accounted for. That's it. Tool 1 to tool 30. If we need 34, 35 tools, we simply redesign our products. So we don't need to use a 34th or 35th tool. Or even like, it's common for drills to be swapped in and out. If it's a short run, sometimes it makes sense to pre-drill a hole with a standardized tool and then just come in and just open it up really quick with an end mill. I know I'm gonna get some disagreement about this. We don't do that because we just redesign the size of the hole to use one of our standard drill sizes. But as long as we're not touching off tool lengths, changing tools, messing with collets, man, we fly through setups. The other thing we do is we standardize offsets. Now, for example, on our vacuum chucks, we always go for the back left corner of the chuck as our origin. On our Pro pallet systems, we use the center of the round pin and the top of any one of the 4 pads for our Z. That gives us a Z0 and the X and Y0. And then we fully model up our pallet, our fixture, and then our parts on top in Fusion 360 we're almost confident enough where we can take a new program, load it, use a known work offset, hit start and walk away. We know our tools because we use standardized tools. We know all their offsets, those don't change, and then our recorded tool offsets for either pro, things like that. Oh, our rotovice also, the far left, well, if you're looking into the machine, the far right edge of the rotovice will be our X0. Our Z0 is the center of rotation in Z, and then Y as well, center of rotation. That way we just bring in the model into Fusion, again, model up, again, almost hit cycle start, walk away. So we don't spend a lot of time taking tool offsets or finding origins. Only one of our 8 machines has a probe on it, and that's because the process dictates that. All the others we just use with an edge finder or a Heimer gauge just to establish that Z0 one time. Now it's a little bit different. I understand if you're a job shop, you're always picking up edges, high mix type things. Yes, a probe makes sense, but for us, we just really haven't needed it. We actually use the table mounted tool probe to capture our height offsets. So we'll just borrow a few seconds of time in that machine, our VF2, our third VF2, to get our tool length offsets. That's then recorded on a card that travels with the tool. So if we pull it out of one of the other 3 machines where the tools float in and out, because we're doing mix of cast iron or stainless steel or aluminum sometimes, we may borrow tools, swap them out. Once we take a tool out, we clip that card on it, put that tool in the next machine, and then we have some 3D printed tool tag holders that if it goes into tool 7, it goes into card slot 7. I'm gonna do a follow-up video about that because I get a lot of questions about that as well. And finally, how do we reduce crashes? So crashes are pretty devastating. They're bound to happen a handful of times in a machinist's career. I saw on Instagram, my buddy posted about having crash dreams where it's rapiding down to 0 and you're holding feed hold, E-stop, reset, and it just buries itself. Yes, I've had those dreams too. Every single one of my machinists has had the same dream too. It's a nightmare. How does that not happen in the real world? Well, I'm gonna give you another Haas tip. Go to settings, type in setting 103, find it, turn it on. Now what setting 103 does is it turns the cycle start button into a combination between start and feed hold. You ever done that 1-2 button press when you're like inching down in Z to make sure you got your Z set? You don't need to do that. You can hold down the cycle start button. As soon as you let go, it feed holds. This is great. We also put it, of course, in 25 or 5% rapids. That's an easy trick. But that setting 103 is great for Haas machines. It works pretty much on every generation. We've got one machine that's a model year 2000. We've got our latest one is a 2018 model. So it works over all the years. So that's how we don't crash. On the Doosan lathes, I'm not a lathe guy, but he's just really careful. So maybe we'll bring him on for another Q&A to talk about how he doesn't crash the lathes. He's worked for me for 5 years, never once crashed the lathe, going back about 6 years in his previous job. So he's kind of due. It's kind of scary, but so far, so good. Hey, that's it for this episode of Pierson Workholding Q&A. If you like this content, maybe we've earned your subscription. And if we have, hit that notification bell. You'll be one of the first ones to watch the next episode. Now, if you have other questions that we didn't answer, general machining questions, please add it to the comments section. We'd love to chime in or save it for a future episode. So until then, go innovate your production.